Good morning. My name is Luis Miguel Alzate Corral. I study in the Autonoma de Occidente University. I find myself finishing undergraduate schedules, and today I present the final project of Control 2 schedules. The presentation will demonstrate that using the methods of anti-windup, Smith predictor, PID, and feed-forward control, you can create a fast control in response time and with minimal overshot to possible disturbance in the development of the process.
Okay, now, first step, the characterization of the chosen plan is obtained. In this case, it is taken from the Cascade control repo for a head chamber. Then, each of the models with feedback is simulated in MATLAB to observe the response to a step, and the simulation of the Cascade process is also carried out. It is observed that for all three cases, the system stabilizes. However, does not stabilize at the indicated reference equals to one value. This is because there is not control over the plant. Next, for this Cascade process, it is decided to make a page controller. It is observed that the response obtained from the Cascade process with two-page control is. In this answer, it is observed that the system stabilizes in the value of reference. Also, the system has a maximum peak of 3% and a stabilization time of 116 seconds approximately. Stabilization time can improve as well as maximum peak. Now, to be able to make the plan work with the real condition, a saturator is added. It simulates the real working range of the plant. A strategy used to prevent the plant from becoming unstable is to use a method called anti-window. That consists of adding for a window gain that will allow me to regulate the effect to the saturator, placing this before inserting the integrator. The response obtained is equals to payday, although in this case at the plant is added real world conditions. For the Smith predictor design, first I extract the dynamic system of Cascade process of a exchange paper, where this system is represented two transfer functions. One is behavior value and the other is the behavior temperature process. Form the Cascade process of head shank. After designing the predictor simulation in MATLAB, I make the code where I will get the control values. Now, the next step is convert the function transfer in state variables. For the bubble model, this is the diagonalized to process to extract the matrix A. The matrix B is matrix of in, and the matrix C is matrix of out. Also, I repeat the same process for the temperature model. As assumed, the poles of the system are also obtained from the diagonalized system. In the design of control valve, the desired poles are equal to the diagonal matrix A. With these poles, it is observed that the system has a shortened stabilization time, compared with poles in -1 value. We continue with the design of the observer continuous follower, using the desired poles, adding one more to increase the order of the system, for half the equal size to matrix increase A and matrix increase B. Finally, the proportional and integral values of our model. The same process is used for the design the observer follower a plan of temperature. Now everything becomes discrete time. A sample time is added and the previously used desired matrix and poles are converted to discrete time. This will help you to design the follower with the observer in discrete time for the two model of process and thus be able to mount software that will control the applied process. These last two parameters correspond to the delay time and filter value of the Smith predictor. The next step is evaluated the code in Simulink. I obtained two responses. The blue line is the Smith predictor value response with stabilization time equals to 4 seconds, using rule of 98% stabilization value. Also, with poles equals to matrix A. The red line is the Smith predictor temperature response with stabilization time 7 seconds, using rule of 98% stabilization value. In this case, poles are modified because the poles ubicated in the matrix A is now have a fast response. Next, and to continue improving the proposed control, the design of a feed-forward control or anticipatory control will be carried out, which allows eliminating the disturbance that may occur in the Cascade process. This control is used the function resulting GFF from the combination of the model of valve and the model of the temperature process. This is the result of this operation. The value of 1.98 is a gain, and the resulting function is added a transfer function, and the perturbation value is 1. Now I obtain the simulation. The result of simulation for the process in Cascade is in this graphic, I observe the stabilization time is 220 and the maximum peak is 48% and the perturbation value is 1. Next, I added a 1 delay for the process and compare these results. In this graphic, the blue line is the feed-forward control without delay. This has a stabilization time of 220 and the maximum peak is 48. While the purple line is the feed-forward control with delay, has a stabilization time is 200 and the maximum peak is 49. It can be seen that although the delay increases the maximum peak, it minimizes the stabilization time. Now, I agree a new values of payday. These values optimized the response more than previous ones. And I agree a one Smith predictor for temperature process. The results are compared with other simulation. In the simulation, I agree the anti-window. And the response is almost the same, with the difference that you can insert the real working range, modifying the saturation value. In addition, it is observed that the stabilization time improved considerably. It is now 80. And the maximum peak decreased a little. It is now 46%. Okay, for the ultimate and definitive simulation, I have decided to add the light to the valve 2 and the leaf anti-window. My ultimate design is this. Okay, in this graphic, the stabilization time is 16 approximately, and the maximum peak is 6%. Finally, I will compare control design previously in order to observe the best response. In conclusion, they are all controlled since they stabilize at a value. However, the best response obtained was the one that contains the complete process in Cascade with its respective Smith predictor, anti-wind-up for real range, and disturbance control.
Okay, I finished the exposition. Thank you for your pay attention.